Assalamu alaikum everyone, welcome to the second video of this tutorial series. In this video I will show you logging and extracting prompt data. Previously you saw we use cargo run to start our server. Then if we change something, then we restart our server, then we use Ctrl C and stop it, and then again we run cargo run. But that is too tedious. We can use cargo watch to restart our server every time we change something inside our project. But there is another way we can run this command. So we can use a justfile, which is like makefile, to automate this process. So go ahead and install justfile. I use Homebrew to install. Check the official documentation how to install on your system. At the root of this project, create a new file, call it justfile, without any space and without any file extension. Then you might also wanna add the extension for justfile. This extension. Now inside this file, add a recipe run, then go to next line, add a tab, then add our command, which is cargo run -c for clean up the screen before it runs the command, and then -x to execute run command. Now go to the terminal and then type just run. This will be watch. I made a mistake. Then again just run, and you can see that it ran this command and started our server. So if I go to the main.rs and add a empty line, then you will see it will restart. Now let's just go ahead and add some logging to our app. Open cargo.toml file, then add tracing for structured logs and spans, and tracing subscriber to filter, format and route those logs. And the features is environment filter. Now close that file. Now go ahead and create another module. So open lib.rs and add a public mod, which is, let's call it init. And inside the src folder, create a init.rs file. Inside that, create a public function called logging. Import fmt subscriber from tracing subscriber. Let's create subscriber. Now you can customize your tracing from here. You can see there are so many ways you can configure. For now, I'm going to set default tracing to info. And then finish. Now set this subscriber to default global tracing subscriber. Now this returns a result, which means this can return error type. So unlike before, we won't call unwrap. Instead we will call expect and then pass a message. And now what expect will do is, if there is any error, it will panic with this message, so we can debug it. Now go to main.rs file. We have to import init module, then call login, then create a log here with tracing label info. Message is server is starting. And you can see we get our very first log. Inside the logging function, I set the maximum tracing level to info, There are 5 types of labels. I'm gonna copy and paste some code to explain to you. No need to type if you are following along. So these are the 5 types of tracing labels. So trace would be the least severe and the error would be the most severe. So when we set our label to info, then only info and anything more severe than info will be logged. So in our case, we set the label to info, so we get the info, warn, and error. But if we set to, for example, trace, and then if it reloads, then you can see that we get all types of log, but we don't want to hard code our log label. Instead, we want to pass environment variable to control our log label. For that, create a environment filter. Let's call it filter, and import the environment filter from tracing subscriber. And then with default directive, so we will set our default log label to info. So set that to info, call it into. Now call from environment Lucy, and this will return environment filter. Now inside the subscriber, get rid of this hard-coded log label, then add with environment filter, then pass our filter. If you notice closely, we get our target name logged, which we mentioned inside our cargo.toml file. And if we add a test log, then we also get the module name log. Now this will be useful if you have multiple crates, either local private or third-party crates you add as dependency. If they have logging, then you get the name and module name. In our case, our app is small and I don't like to log. If you want, you can keep it. So I'm going to disable it. Set the with target to false. So now we can see we don't get any target name. Now go to main.rs file. We added a log when the server is starting. We also wanna log the address and port. So extract that to a variable. You can definitely pass this from environment variable. Cut this thing. Paste that. Then after this, we can add another log, listening app. And you can see it's being logged. Now instead of unwrapping the error, we can add an expect here and set a message to fail to bind address. And then again, when we start our server, we wanna add another expect. So we get an error message when the server does crash. Now we set environment filter, but we never pass any environment variable for logging. So inside the justfile, add an environment variable, rust log, and it will be debug. Make sure there is a tab. Now we have to stop our server and restart to get effect of this environment variable. Now if I just go to main.rs file and add a debug string, and we get the debug log. Anyway, get rid of it. Now if we go to our website and then reload, then we don't get any log for that. So we have to log each request and response. So to do that, we have to add a features to Tower HTTP crates. So open cargo.toml file and add trace features to Tower HTTP. Close that file. Now go to route module, and at the end of all routes, add a new layer. Because remember, I told you that middlewares are executed from bottom to top. We want logging to be the first middleware to be executed. We have to first import trace layer. So trace and trace layer from Tawa HTTP, and here call trace layer and then new for HTTP, this function which will give us some basic logging. If I go to the browser and reload, then we get some logging. As you can see, we get very basic log, and it's okay, you can keep it. But we want more verbose custom structured log. We don't get any response log, so we would like to log the response time, IP address, and so on. On this function, call another function, just get some space, then call make span width. It takes an argument which is a reference type of request with generic type body, and we can ignore that here using underscore. Now we have to import that, which is from Axum, request from HTTP, and body from body. Inside the closure, create an info span tracing and call it HTTP request. Now I spell it wrong, it will be request. So we will chain three functions: on request, on response, and on failure, and all of them takes a closure. So instead of nesting closure, we can extract them to a different function. So go ahead and create a function on request. The on request function takes two arguments. The first is request, similar to make span width, which is reference request, and the second is reference span. We won't use it, so add underscore. Now import span from tracing. Inside this function, create an input tracing, type request started, colon, then first method, and then path. So request method, which will return the method, and the path is request.uri.path. Now create on response function, which takes three arguments. First is response, which will be referenced response type, and the latency of type duration, and span, which we don't care, so we can add underscore. Now import duration from std time. Inside this, add a info log, then response generated, colon, then status, and the latency. Now pass these values. Now we won't get any autocomplete here if you're just wondering, because we are inside macros. If you want, you can extract this to a variable, like for example, let me show you. Now you can see we get the IntelliSense. And then the latency. Now latency doesn't implement the display trait, so we have to debug print. And finally, create the onPaleo. First, it takes error, which is of type server errors failure class. That's mouthful. And latency and span. Now import this from Tawa HTTP. Now inside this function, add an error log. Type request failed. And then the debug print the error message and the latency. Error and latency. Now pass these two values. And with that, if we go back to our browser and then reload our browser, then we get to see the request and response log. Now do a hard reload, Command-Shift-R. Then you can see we get 404 status error accessing tab icon. And if we go back to the browser, then inspect the page, then you can see we get the same error in the browser console. And we can fix that easily. Go to index.html and then add a link tag to our fab icon, which is inside the static image folder. And then we can again go back to our browser and then Command-Shift-R. Now you can see that we have a fab icon. Now close that file. So let's go ahead and work on sign up. So open cargo.toml, then add serde with features derive, and then add validator with features derive. Then close that file. Then open signup.html file. First add the CSS block and point to auth.css file. So you also have to add the CSS block to index.html file. So inside the head, add the CSS block. Now close that file. So get rid of this h1 tag. First add the auth container. Then inside that add h1 tag, which is the auth heading. Then add the form which will make post request at /signup route. Then inside that add the input field for email. Then add another input field for password, and then a button which is of type submit button, and this is important. And then outside of this form add another form, and inside that add a button which will make get request to /login. So basically this button will be used to toggle between sign up and sign in page. So once it reloads, we can go back to our website and check it. Reload the page and then go to sign up, and we can see that our sign up form is appeared. Now we have to extract the form data. So to do that, create a submodule inside models folder, call it user form model.rs file. We have to add this to mod.rs. So pubmod user form model, close that file. First import deserialize from serde. Then create a public struct, call it user form model. And also add the derive macro and deserialize, because we want to deserialize the form data. Now create two public fields, email of type string and password of type string. Now go to the routes.rs file. On the signup route, we already have a get method. Now we have to add a post method. Now add a post method, then register a handler. Let's call it post signup handler. this handler doesn't exist. So copy the name, then open auth.rs. Then after the signup handler, create a public async function and paste that name, returns response. We have to import the redirect from Axum response. So redirect to / which is the home page, then call into response. Now we need a prom extractor which is specific to the Axum, which I will explain in a bit. But we have to first import pom from Axum. So add these curly braces, then comma, then pom. Make sure that you import from Axum, not response. Then as a function argument, add the pom extractor. Pom, then the variable, let's call it user pom, and which will be of type pom, and the generic type is user form model. Now we have to import that form models. So again, add the curly braces, then add user forms model, then user form model. Now create an info log, and let's say that the email is, and the password is, and then pass user email and then user password. Now inside the routes.rs, we have to import this post signup handler. So we are importing the signup handler. Now import the post signup handler. Error should go away. And one thing is I forgot to mention, inside the user form model, the name of the field, email and password. It has to be email and password because this name has to match with this name. So if it was, for example, email 2, so we would name it email 2. I hope it makes sense to you. Let's give it a try and then go to the reload, sign up, type anything, submit that. Now it's redirected, which means we didn't get any error on client side. We get the email and password being logged, which means we are successfully being able to extract the email and password from data. Told you before that I will explain you what is Axum extractor. If you notice that our handler doesn't take any argument, in other framework you might have seen that you have two arguments, request and response, and you tap into the request object and then you get access to the form data or something. But Axum doesn't have it. So Axum has something called extractor. So it provides some handy tool to extract part of the request. So for example, if we want to extract path, then we have a path extractor. If we want to extract query, then we have query extractor. And we also have of course, we have JSON extractor and form extractor. And the JSON extractor and form extractor has to be the last argument because it consumes the request body. And this is basically destructuring the form extractor. So for example, let me just remove this. Now we have a user form which is of type form of generic type user model. Now if I just go ahead and create a variable, let's call it A and user form and then 0 because it has only one field. You can use index to access tuples field. So you can see that we get user form model, which is the type of our form extractor. So instead of extracting to a variable, we can destructure it within the argument, which is much better. Alright, I was trying to add a validation and it became very long. So I'm going to wrap this video and definitely watch the next one and get subscribed to be notified. If you like this video, then give me a like and I will see you in the next one. Assalamu alaikum.